Hello guys, welcome to my new video, and in this video we are going to talk about Ospf Protocol, and we are going to fully explain how it works and what are the rules when configuring Ospf to form a neighbor relationship. Okay, so Ospf stands for Open Shortest Path First. Okay, and it is a link state routing protocol. It is also a routing protocol which was developed by the IEEE, so it was not developed by any like companies like Cisco or Juniper or anything like that. So this routing protocol can be used in any router. So you can use an HP router, a Juniper router, an Avatar router, and it will work. And you can also combine different routers like a Juniper and a Cisco router, and you use Ospf and they will be able to communicate with each other. Okay, and this routing protocol is also a classless, which means that you can use any subnet mask that you want. So you can do like a subnetting mask. You can use a 232 mask. You don't need to use like a class full mask like when you are using RIP version 1. I believe RIP is a class full routing protocol. It's really old and nobody uses it anymore. And Ospf is also scalable to 2 areas, right? So you can divide your network into areas, and that way you can cut down entries in the link state database and pushing responsibilities of the link state database maintenance to area border routers. Okay, and Ospf uses a Exstart algorithm, and they communicate. Ospf communicates, since their link states and all that, on multicast multicast IP address 224.0.0.5 and DR and BDR. To communicate with the DR and the BDR, we use 224.0.0.6. And guess who uses 224.0.0.10? EIGRP, just in case you didn't know. Okay, so here are the requirements or the rules that you need to follow when you are configuring EIGRP. I mean, not EIGRP, Ospf. So area ID, both interfaces should be in the same area. If they're not in the same area, it is not going to work. So let's go ahead and see that. To see if that is true, let's go ahead to first, let's make this bigger so you guys can see it. Font, let's make it 10. So I have this network over here. I haven't set up with anything, so nothing is configured in this topology. If you want to download it, you can go ahead to the link in the description below, so you can download it already. If not, you can put a switch in 3 routers and then plug them in, and we're going to configure. So let's go to interface, gigabit 00, IP address 192.168.10.2. Not shut down. Here we go. We can just exit out of here. Let's give it a host name of R2. Let's go ahead to R1 and do the same thing we did. We're not going to configure Ospf yet. Let's give it a host name first of R1. Go to interface gigabit 00. Give it its IP address. Not shut down. Let's go ahead to R0. Make this bigger. Host name R0. Interface gigabit 00. That. This is going to be that 10.3. Let's shut down. Let's verify that. For this one, I put 3.3. This is .1, and this is .2. This is actually, yeah, .2. And this is .3. Okay, so they are all configured. What we can do now to configure OSPF, you go to the configuration, and then we do router OSPF, and then if you do a question mark, we have to give it a process ID. The process ID do not need to match for all the routers. You can have any numbers from 1 to 65,535. So a lot of process IDs. Okay, and they do not need to match. Then we can do network, and let's add my network 192.168.10.0, and here you need to add a wildcard mask. Okay, and let's see what we were talking about. So area ID, so the interfaces need to be, both interfaces need to be in the same area. So we're going to verify that it works. So let's put this in area 0. We can even just copy this because they're all in the same network. Router OSPF. Now we're going to give a process ID of 2 for this one, and you can see that they do not need to match. Area 0, and if you click on fast forward, you're going to be that we have a neighbor relationship with 192.168.10.2, which is this one right here. Okay, now let's go over here, exit router OSPF, process ID of, let's give a process ID of 8, network. But now for this one, we're going to have to add it to area 1, and as you can see, these two routers are in area 0, so they were able to form a relationship. Since this one is in area 1, it won't be able to form a relationship. And as you can see, we receive an error, mismatch area ID. So if you go to N and show IP OSPF neighbor, we don't have any, right? But if we can just copy this and go to router 1, and it, we can see that we have a neighbor relationship over here, right? So this one did not form a neighbor relationship because one of the rules is that the interfaces needs to be in the same area, and since this one is not in the same area, we're gonna have to fix that. Config T, router OSPF, what was that we gave it? OSPF area 1. Let's put on area. And we need to actually be on the same OSPF for this router where we configure, which it was 8, and network 192.168.10.0 255 area 1. Let's say, let's delete that and let's add it to area 0. And now if you fast forward, we should be able now show IP OSPF neighbor. You can see that now we have 2 neighbors, which is 10.2, which is router 2, and 10.1, which is router 1. So if you go over here we can see that we have a neighbor relationship with 2. Let's take a look over here. Show IP Ospf neighbor. And we see that we have a neighbor which is 168.10.1, which is this router over here. Okay, so as you can see, the area IDs need to match, otherwise they won't be able to form a neighbor relationship. Okay, and the other one is authentication. So if you're doing authentication, routers need to be on the same password. If do not have the same password, then they won't be able to work. Okay, and the other one is hello and dead intervals. So the default dead intervals is 40 seconds. If a router does not receive hello packets in 40 seconds from a neighbor, it will declare that as dead. And also the hello interval is the length of time in seconds between the hello packets. The default hello interval is 10. So the dead interval needs to be 4 times the hello interval in seconds. So as you can see, 4 times 10 is 40. Okay, so these need to match. If they do not match, they won't be able to form a neighbor relationship. Okay, so if we go and change that, let's see if we can change that in. Let's change that in router 1. Config T, and I believe you need to do it from the gigabit interface. I think you do Ospf hello interval. Let's put it at like 15, and let's fast forward. As you can see, the neighbor relationship went down because the hello intervals do not match the same hello intervals as router 2 and router 0, because R2 and R0, the hello intervals are equal to 10, and since this one is equal to 15, the neighbor relationship goes down. And you can do show IP Ospf neighbor. You can see that we don't have any neighbors there. So let's go back and add it to 10, and if we fast forward, now you can see that we have formed a neighbor relationship, and there it is. So the neighbor relationship went up. Okay, and also if you're doing IP Ospf that interval, set it to 60. If the dead interval does not match, because these two, router 2 and R0, are equal to 40, what's going to happen is that this one is going to go down. There we go. I just click on fast forward time right here, so we don't have to wait. And as you can see, now it went down, right? If we do a show IP Ospf neighbor, we don't have any. So let's go ahead and put it back to 40. Okay. And you can see right here that it is initiating. If we fast forward, you can see that now we have a neighbor relationship. So if we set this to hello intervals to 20, you need to set the dead interval to 4 times 20 is equals to 80. Okay, so you need to set this up. Let's open a text editor right here. And let's edit this. Okay, like this. As you can see, let's just wait. You can see that it went down. Okay, because they're not matching, but since you want them to be 20 and 80, what you can do is go to this interface, or go to this router and go to the interface, gigabit 0, paste that there. Let's fast forward, and you're going to see that we have formed a neighbor relationship with router 1. because these two are matching the hello interval in seconds and the dead intervals. But this one went down and we don't have any relationship. So you can go show IP OSPF neighbor, you don't have any. So let's go ahead and configure that. Interface gigabit 00 and paste that there. And now if you fast forward and do show IP OSPF neighbor, you can see that it is initiating. It's just taking a little bit longer because we put this to 20 seconds and that's why it's taking so long. And for some reason it's not working. I guess because it is the wait is too long. So let's go ahead and set it back up to 10 and 40 right here. And let's add this configuration for them. So we are in the same interface, so just paste that there. Paste this over here. And paste it over here as well. Let's go ahead and fast forward the time. Do show IP OSPF neighbor. Here we go. We have a neighbor relationship with router 2. Over here, if we do show IP OSPF neighbor, you can see that we have a neighbor relationship. Okay, so it is working. Okay, so the hello intervals and the dead intervals need to match for the routers on the same area for it to be able to form a neighbor relationship. Okay, so if we go back, let's see what else we have. Also, the stub flag needs to be the same. So this value indicates that whether sending router belongs to a stub area or not. Routers who want to build an OSPF neighborship must have the same stub area flag. If they do not have the same stub area flag, they won't be able to form a neighbor relationship. Okay. And the other one is the subnet. They need to be in the same subnet. If they're not in the same subnet, they won't be able to form a neighbor relationship. So let's go ahead and take a look at that. So if we go, we are in the same interface gigabit 00. If we do IP address 192.168.10.10. Let's say that 20.1 255.255.255.0. You can see that when we configure it and they're not on the same since they're not on the same subnet, it went down. So it went from full to down, and the neighbor also went down. And you can verify that by doing show IP OSPF neighbor. You can see that we have no neighbors. So if we put it back to 10.1, we are able to form a neighbor relationship. Okay, and you can verify that by doing a show IP OSPF neighbor, and you can see right here that we have a neighbor relationship. So that is another one. And the last one is the MTU, which is the maximum transmission unit. It's not part of the compulsory matching conditions. Still, we should match this value. If this value does not match, routers may stuck in the Exstart exchange stage. Okay, so it is saying right here that it doesn't really matter, but it could get stuck in the Exstart exchange stage. Okay, so that is another rule for you guys. And in the next video, we are going to talk about understanding the designated router and the backup designated router selection. Okay, so thank you guys for watching this video, and I'll see you on the next one. See you guys. Bye bye.